A mean is similar to what we think of as an average. We will estimate the population mean with the sample mean. Mu is the population mean. X bar is the sample mean. We will use the formula for the error. Error is t times standard deviation divided by the square root of n, where s is the sample mean and n is the number in the sample. We will first need to discuss t, which is called the t-distribution or the student's t-distribution. It is similar to the standard normal distribution, z-scores. The t-distribution uses a value called degrees of freedom. df is the abbreviation. df equals n minus 1, where n is the number in the sample. To find the t-critical values, we will use the t-distribution table A3, and this is in the book. To find the t-value for a given confidence level, change the confidence level to a decimal. Calculate 1 minus that decimal. This is called the area in two tails. Then find the row for df and use the area in two tails value. Example 1, you will need to be looking at the t-distribution table. It can be found in MyMathLab. On the left menu, you'll see tables. Find t for n equals 19 and 95% confidence. df equals 19 minus 1 equals 18. 1 minus 0.95 is 0.05. Go to the row for df equals 18 and an area in two tails for 0.05. T equals 2.101. Example 2. Find t for n equals 25, 90%. df equals 25 minus 1 is 24. 1 minus 0.9 is 0.10. Go to the row for df is 24 and an area in two tails for 0.1. T equals 1.711. Find t for n equals 25, 96% confidence interval. df equals 25 minus 1 is 24. 1 minus 0.96 is 0.04. In this case, we'll use technology to find t. This means the area in two tails is 0.04. So the area in one tail is 0.04 divided by 2 is 2. Under Question Help, click StatCrunch, Stat, Calculators, T. Put in the correct df. Change the symbol to greater than or equal to. Delete what is to the right of the greater than and put in 0.02. The t-value is what gets filled in to the right. Okay, I should say what gets filled in to the right of the greater than, and that is 2.1715. Now we will find the error and the interval. Find a 96% confidence interval for mu if the sample mean is 108, sample standard deviation S equals 10, sample size of 25. We found the t-value is 2.1715 in the last example. Error is t times s over the square root of n. T we found to be 2.1715. S is 10. Divide by the square root of n, which is the sample size of 25. The square root of 25 is 5. So 10 divided by 5 is 2 times the 2.17. That's our error. The lower bound is the sample mean minus error. The upper bound is sample mean plus error. Example 4, a random sample of 51 fatal crashes where the driver had a positive blood alcohol concentration, shows a mean of 0.16 grams per deciliter with a standard deviation of 0.01. A histogram shows that it's skewed. Why is a large sample size needed? Since the sample size is skewed, the large sample size is needed, so the distribution is approximately normal. If there were 25,000 fatal crashes, why does this satisfy the requirements? The sample size is likely less than 5% of the population. Find the 90% confidence interval for the mean blood alcohol concentration. Find the T critical value. DF equals 51, I should say 51 minus 1 equals to 51 minus 1 equals to 50. To find the t-value, okay, 1 minus 0.9 is 0.10, area and 2 tails. Use table A3, area and 2 tails of 0.1 with a DF of 50, and we get t equals 1.676. So the error is t times s divided by the square root of n. The lower bound is the mean, 0.16, minus the error, and the upper bound is the mean, 0.167, plus the error. Is it possible that the true mean is 0.08? This is not in the interval. It is possible that this is the true mean, but it's not likely. What if we are given the lower and upper bounds and we want the point estimate? Okay, example 5. If the lower bound's 20 and the upper bound's 30, the point estimate is going to be the exact middle of the lower and uppers, and this can be found by averaging the lower and upper bounds. So 20 plus 30 divided by 2 is 25. The error can be found by taking the upper bound, subtracting the point estimate. The upper bound was 30. The point estimate is the mean, 25, so the error is 5. You can see that 25 is in the middle of 20 and 30. 25 minus 5 would be 20, and then 25 plus 5 would be 30. Okay, the interval is the mean minus error and mean plus error. That's the end of this lesson.